So we're going to work on how we use some of these ideas to solve problems. And we're going to look in Chapter 3, Problem 112. And this, you can read the problem here. And I'm going to set up a drawing for it while you do that. So we have a runner who runs 100 meters. The first runner starts here, gets to the end, or 100 meters, in a time of 11.2 seconds. The second runner runs the same distance in a time of 11.6 seconds. And the problem asks that to find out how far the second place finisher is. So how far means a distance. So for us, that means an x value. And it says assume the velocity is constant. And constant velocity means we can say v is equal to then our delta x, delta t. The direction of the velocity, if you want to go ahead and do the vector, is going to be in the i-hat direction. But we're going to really be focusing on this delta x, delta t for each of the racers. And so what we need to do is, there are a number of ways to solve this problem. And I'm going to do it first with the equation, and then I'm going to do it a second way graphically so you can see different ways to set this up. So if we look with constant v, we could find the velocity for the first runner. So the first runner is right here. And so we can say then v1 is equal to delta x, the distance that the first runner went, over her time. So that would be 100 meters over 11.2 seconds. And we can do the same thing for the second runner. So v2 for the second runner, slower but same distance, delta x, delta t is equal to 100 meters over 11.6 seconds. And that's fine, but that's not anything that the problem asked us for. So what the problem asked us for was to then find how far the second runner was behind the first runner. Say the second runner ended up here when the first runner crossed the finish line, right? So we want this distance. And so what we can do is say we can reuse this equation for v2 is equal to the distance that the second runner went in some time that we're interested in. And what we want to do is find a new distance, so a new value here, and the time we want is the time of the first runner, right? So this time would be 11.2 seconds. But she's still running with the same speed, so we can put in our value for v2 that we got right over here. So if we put all of this in, so we get 100 meters over 11.6 seconds is equal to the distance that x2 went, okay, delta x2 in 11.2 seconds. Then that, if we plug that into our calculator, that gives us a value of 96.6 meters. And so, of course, that means if we take the full 100 meters and we subtract this 96.6 meters, we find out that, of course, she is 3.4 meters behind the winner of the race. Okay, now that's sort of the way you might go about it, the logical way to go about it, but I want to point out that we can put all of this in a graphical form, and sometimes that's an easier way to solve the problem. So if this is a way that appeals to you, then please feel free to use it. Okay, so the graphical way would say let's plot a usual x versus t graph, and we can do this for both of the runners. So we'll put runner number 1 in, and she goes to this distance, 100 meters, in a time of 11.2 seconds. Okay? And then the next runner goes a little slower, so the slope isn't as steep. So here's our x2, like this. Okay? And we know that she arrives at 100 meters with 11.6 seconds. And what we want to find is this distance right here. Okay, this red, I'm making it black, this purpley black distance right here. That's the distance that she's behind right at this 11 point, the second runner's behind at 11.2 seconds. So in some ways you can use this graphical method if you like to say, hey, if I know this slope, and the slope of this is just the speed, so the slope is the speed, so is v2, right? Then I know that's the same as the rise over the run. So I can say v2 is this little, I'm going to call this x behind over this difference in time difference, if you like. Right? That's still rise over run. So we can say v2 is equal to this v that you're behind, the x that you're behind, divided by the time difference. And then this is going to give you exactly the same thing. If we plug all of these numbers in, we get 100 meters over 11.6 seconds is equal to this x distance that you were behind, all over the time difference. In this case, that's 0.4 seconds, right? That's that piece that's right up here, right? That's that 4 seconds. And if you solve that out, you get the x that you're behind is equal to 3.4 meters. So either way you can get that, but in some ways the graphical method is just a little bit faster because that you can see on the graph the little piece that you're trying to solve for. So sometimes putting things in a graphical format will really help you out. It usually doesn't hurt to do it this way. So sometimes putting it this way is a way to get at what it is that you're trying to measure.